All right. Good morning, good afternoon, good evening, wherever you folks are streaming from. Um, let's see. Let me just make sure. Okay, we're good. So, how are you folks doing? Hope you're doing all right on this wonderful Wednesday. Um, got my NASA hat on today, NASA shirt on, getting ready for the launch. Don't have any SpaceX gear, um, but yeah, just really excited for today. I think 4:30 p.m. I don't know if they confirmed that they're going to launch today. Basically, the first manned space shuttle since like 2011 or something like that. Um, that's it's really exciting. So I'm really looking forward to that. I'll probably be tuning in around that time. Uh, should be really exciting. Yeah, I didn't stream on Monday because it was a holiday, or at least it was here in the United States. So just getting some very much needed rest and relaxation wherever I could. But yeah, so I'm back today, and we're going to continue implementing Stamina, the static malware analysis using deep learning, and we're going to be using F Sharp and .NET and all the things that we know and love to try to implement that. We got most of the way there last time. We were able to get over the hurdle, or at least I think we were able to get over the hurdle of converting a byte, the binary representation of a file into an image. We were able to do that, and I'm not quite happy with how that looks at the moment. There are still some tweaks and some changes that I want to make to it, but I think overall, at least as a proof of concept, we got it to work. And let me just open this up and open up the project. But I thought that before we started, I could kind of talk about a few things that are happening and a few things that you might be interested in, especially if you are interested in doing machine learning, if you're in the .NET space, and you want to learn a little bit more about machine learning. If you haven't heard of it before, there is the virtual ML.NET conference, which is happening this Friday and Saturday. So 2 days away. I'm really excited. It's uh, it's gonna be on the first day. We're gonna have a um, full day workshop. Let me see if I can find it here. There we go. Yep. So on Friday, we're going to have a workshop that's going to cover the ins and outs of machine learning and anything from getting your data, sort of transforming your data and manipulating your data, all the way to consuming your model. So training a model, consuming the model inside of a web application, and then we're going to touch on some topics like deep learning and ML ops, which are slightly more advanced topics, but it's definitely something that should be top of mind as you're implementing your solutions, right? And that's going to be delivered by Bree and yours truly. So I'm really looking forward to that. And then on Saturday, we have a ton of really nice workshops planned that they're going to be delivered by the community. We're going to start off with AI ethics, which is, again, really, really important. It's a really important topic when you're building these machine learning models. I talked a little bit about this on the last stream about how uh, Microsoft uh, Microsoft has developed this framework for doing responsible machine learning, anywhere from protecting your data and understanding what your model or why your model is making the decisions that it's making, as well as protecting your data through differential privacy and homomorphic encryption and being able to monitor and control what exactly is going on throughout your pipeline and be able to inspect the pipeline with techniques such as ML ops, right? So being responsible with how you build these systems, it's a huge deal. And ethics goes a long way with that. We're gonna get an intro. So for folks who maybe couldn't join on Friday, that you're gonna get a bit of a primer on machine learning and ML.net. And this should be really nice. And even if you did attend the workshop, right, you definitely want to make this one. It's really great content, and at the very least, it's going to be a refresher from Saturday, right? And it's really going to give you a different perspective, not so much from sort of how Bree and I see ML.net, but more from how the community sees ML.net. Then we're going to have a data scientist join us from Microsoft, and he's going to answer any questions that you folks may have. So make sure to bring your questions. Then we're going to talk a little bit about transfer learning for deep learning. We're going to talk about using Jupyter notebooks. Daniel has a really nice presentation, and it's using Jupyter notebooks and the .NET kernel, which is something that we've been using on stream here. He'll be doing some work there with that. We're going to be looking at decision analysis, building chatbots, and we're going to be talking about the data frame API, which we haven't touched on yet in this stream, but at some point we're gonna run into it and we're gonna talk about it. And then finally we have building serverless machine learning APIs with Azure Functions and ML.NET. So again, it's a full day, both Friday and Saturday, and you're gonna get your heart's content of content around machine learning and .NET. So with that, I highly encourage you, if you are interested, or if you're planning on doing any sort of machine learning with your with in your applications, I highly encourage you to attend. And even if you're not, right, it's a way to learn, right, about different tooling. It's a way to learn about what else is out there, right? So yeah, let's see here. Okay. Now we didn't get to go through this last time, but essentially it's a recap. Sergey's blog or newsletter called F Sharp Weekly. He sends these out weekly, and here he talks about a lot of what's going on in the .NET space. It's focused more on the F Sharp side of things, which is what we've been doing on this stream since the beginning. But it's just essentially doing a recap, right? Because that was sort of the big news last week. Build. Okay. So a few things that I thought would be interesting, right, are these F Sharp 5 and F Sharp tools updates. Okay. So there's a lot of improvements and a lot of work going into F Sharp 5, and it's going to be just like .NET 5. It's going to be a really nice release pack with tons of features. And one thing some of the things that are happening are so with C# 8, it provided the ability to define interfaces with default implementations, right? Whether you like that or not, or whether you want to use that or not, that's that's to each their own, right? I'm sure that in certain scenarios it might make sense to do this. So what F Sharp has done is they've introduced the ability to interop with those default interfaces, right? So that's really neat. It's in terms of being able to support and provide interoperability with these other tools. You essentially can do that now with F Sharp 5, or you're going to be able to do that with F Sharp 5. Then in terms of performance improvements, as you can see with .NET Core 3.1, I'm not quite sure if this is measured in seconds or minutes, but you can see that the compiler has drastically improved in terms of runtime, or I'm not quite sure what this timing is when following running the following commands, right? So if you're building a project, the compiler seems to be performing much better than before, and that's great. In terms of tooling, right? It added the find all references, which has been significant. Let's see what else. So continuing the F sharp journey, this is actually an interesting thing, and I think all of this is relevant and important to us. But the two pieces that I think are of specific or particular interest to us is going to be making F Sharp Jupyter and Visual Studio Code notebooks the best language for data science and analytical work. And there's more this coming, right? We've been doing this on stream for some time, and the experience is good, right? Considering that it's still in its very early stages, but you can tell, or I hope that you've been able to determine that the experience of using .NET in Jupyter notebooks certainly has a lot of useful and very nice features, right? Like there's a it's another way, it's another way of working in code, right? It's another computing environment that provides us interactivity, and for data science and analytical work and machine learning scenarios where it's very experimental, uh, and you kind of have to iterate on things. It makes sense that you would want to have these interactive and visual, highly visual computing environments, and that's sort of where Jupyter Notebooks, Visual Studio Code, and F Sharp can really come in and provide that sort of that need, right? So yeah, I mean that's kind of what's going on there. If you weren't aware, ML.NET Model Builder is now part of Visual Studio. So before, what you had to do was you had to install it as an extension, right? But now it comes with, as of version 16.6, which was released at build, it comes out of the box. So as long as you have the .NET Core workload installed, you should be able to just right click, add machine learning, and you can add this machine learning, and you can start using Model Builder inside for your applications using Visual Studio out of the box, right? So highly encourage you to give that a try. Let's see. There's something else here that was really, really nice. And it's related to projects. I'll get back to that one. Is it here? Where is it? Web UI. Feliz. There we go. Bolero. Okay. So one of the big things that took place, or that was announced at build in the .NET space, was Blazor WebAssembly. So you had Blazor server, which it didn't really use WebAssembly to do its work, and the way that and that was released a while back. I don't remember if it was for .NET Conf in 2019 or if it was for Build 2019, but it was one of those major conferences that it released. However, the team was still working on Blazor WASM, or Blazor WebAssembly, at the time, and essentially it took some time, right? Because it's a relatively new technology, and there's some things that had to work differently, or that work differently as opposed to traditional web technologies, right? So at build last week, Blazor WebAssembly was made generally available, or it was released, right? Not the non-preview version was released, and Bolero is the F sharp, if you will, it's the F sharp version of Blazor, right? So if you want to take advantage of using WASM or WebAssembly, and you want to do it in F sharp, Bolero is a really nice. It's kind of what you want to use for that particular scenario. Just make sure one thing. Sorry. Okay, I'm just trying to make sure that the background noise isn't coming through. So anyway, so Bolero is a way for you to effectively use model view update architecture and WebAssembly, right? So that's another thing that was actually announced, model view update, right? As part of, I believe it was announced as part of MAUI, the multi application UI. I believe that's what it stands for. And so what Bolero does is it gives you that, right? It gives you a function, a way for F# developers to use Blazor using the model view update architecture, and again, using WebAssembly. So definitely worth checking this project out. Okay, so with that, let's go ahead and talk static malware analysis. So if we remember last time where we left off, let me actually open this in VS Code. Okay, that didn't open where I wanted it to, but that's okay. All right, we can just drag it here. So if we remember last time, where we left off was essentially we left off right where. Sorry, give me 1 second. We left off exactly at this point. So we were able to essentially read a file. In this case, it's the. Oops, I can't open it here. But in this case, what we had, if we go to Reactor, nope, not Reactor Workshops, it's going to be in Stamina. And we're going to go to, was it an app? Yeah. Okay. So we had this file here, which is the white paper that was published on this technique called Stamina, or Scalable Deep Learning Approach for Malware Classification. Okay. So essentially, this is what the file looks like. And what we did was we took this, right? We got the bytes for the file, right? If we take a look at or inspect this get file bytes, all it's doing is reading the file, getting the bytes, and converting it to a float array. Then what we do is we define some headers, some footers. Sorry, we we define the dimensions of the image. In this case, it's 2048 by 2048. And then we go ahead and we basically multiply that by 3, right? Because we have RGB values. Then what we do is, in this case, the number of bytes may or may not be less than or equal to, well, actually, most of the time it's going to be less than the number of dimensions, okay? In which case, we're going to need to pad it. So what do we pad it with? We pad it with zeros. And essentially that's what we do. So we pad the array of bytes with zeros until we reach, we basically have an entire array that represents the image filled with pixels, right? And then what we do is we essentially create a bitmap, and then what we do is we go ahead and basically run through this operation, which what it does is it defines the colors of the pixels, and then we basically set each pixel individually. Okay, so this is how far we got. And if we take a look at what it actually looks like, if we run this application and we save, so if we run this application and we take this file, this PDF file, and save it to a JPEG called file image, what this looks like is this right here. Okay, so let me go ahead and Okay, so as you can see, noise, 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 it looks like static. To the human eye, this may look like nothing, but I'm sure that using deep learning, we can essentially make some sense, or use neural networks to make sense of this right here. Okay. Now, the piece that I'm still not quite happy about is, okay, we padded with zeros, but now it's just like, now it's just this portion of the file, and I wonder if the pixels are supposed to be represented in a sort of interleaving manner, or if they're supposed to be represented in a sort of continuous manner. And I don't know, but you know what? I think this is good enough for now. Like I said, I don't think this is what it's supposed to look like. I think the way that it's supposed to look like is essentially have the entire image filled with this static, but that's okay. I mean, we'll go with this, and we'll continue implementing it. So, what I wanted to implement now was this image width and height is determined based on the white paper. So, if we were to open the white paper up again to try to see. So we can take a look here, right? In this case, the number of bytes was more than 1500, right? It's a pretty big file. In which case, we set the image width to 2048 by 2048. So essentially, what we've done is we've used this table to set the image width and the image height. Now, the image height, this is another confusing piece, and I'm trying to keep things proportional. So in this, for the sake of keeping things proportional, I hard coded the image height and the image width to be the same. And I don't think, I mean, that's not how they say that you should do it, but, and I think that that's also the piece that's contributing to the fact that we have a lot of blank space on our screen, right? But for the time being, let's sort of go with that, and And what we can do now is we can basically implement this piece, right? We want to be able to check what the size of the bytes is, right? And then we want to be able to, based on that, determine what the image width and the image height are. Okay, so what we're gonna have to do at that point is we're gonna have to add a function, right, which takes so let's see, let's get image dimensions, and what this is going to take is going to take a bytes file bytes, okay, and then what we're going to do is we want to do match file bytes. Now what this is going to be is it's a file bytes dot length. Trying to think if I should. I think I should just leave it with. So what we're doing is we're gonna do some pattern matching here. So what we want to do is we want to say, let me kind of put this on the left hand side and put this on the right hand side here, just so we're able to check. So if it's between 0 and less than 10, okay, less than 10, let's see, let me see how matching sharp. Okay. Let's take a look at how we pattern match here. Okay. So this is with a point. This is an and. So what about, where's the when? I know that there's when. Let's see. X when x is less than equal to 0 and x is less than 10, then this is 0 and it's less than 10. Then what do we want it to be? I want it to be want this to be 32, right? X when x is greater than 10 and x is less than 30, then what? 64. Right? Why is this complaining? Right, right hand only on demand. Okay. So isn't that how it should be though? And let's see. Oh. Let me go to the and pattern. Yeah, okay. Let's see. X is less than 30. Okay. Let's see here. It's less than 30. So it's going to be equal to 64. And then there's going to be at, whoops. I think we can just copy this all the way down. Okay, so it's going to be 128, 256, 384. That's a weird one. 384, 512, 1024, and 1034. 512, 1024, and what's this one? 2048. Okay. And so 10, and this is going to be 30, 60, 100, 200, 1000, 1500. Okay. Okay, so, and what was this again? So 30, This one's going to be 60. This one's going to be 100. Wait, what? What? 200, 100, 200, 200, 2,000, 1,000, 1,500. Okay. Yep. Okay. I like this. Okay. So get image with. Okay. So this one, I'm gonna say get image with, and then binary file bytes dot length. Okay. And this one image with. Okay. And then what I'm gonna do here is okay, so I think we're okay here. All right, let me try running this and seeing what happens. So if we go to here and we try to debug, what does this look like? Let's see, kind of lost my mouse for a second. Okay, so let's go here and let's try to debug. I don't know if it's because I'm streaming or not, but it seems like it's really slow. All right, so binary file bytes. As we can see, we have an array of 619,956. And because of this, we should expect to see this end up using the 2048. Okay, let's take a look. Okay, yep, nice, 2048. Let's see here, step over. Yep, step over. Okay, and in our logic, the rest should remain the same. Okay, so I'm happy with this. Okay, I'm happy. Now, what if we were to use my binary.txt? So let's switch this up. My binary, oops, .txt, and then if we remember, this is just a text file. All right, that just contains this, and currently our image looks like this. Right, so now we're just gonna have something that shows up at this very top corner. Okay, so let's check it out. So again, same thing. Where is, here's the debugger. Let's start it up. Okay, give it some time. There we go. Okay, so here we are. So this 43, so 43 we should expect it to be at 128. Is that what we're getting? 128. All right. Seems to be working. And then if we go, oh, what happened here? Oh, okay. Yeah, yeah, yeah. Okay. All right. Yes. I get what you're saying. I get what you're complaining. So here what we need is this thing called, I don't know, image with -1. But, I don't know, iters is equal to here. What we want to do is we want to do this, and then here we want it to be image with, okay. All right. So if we try to debug this, now we should be okay. Okay. There we go. And let's start it up. Let's see. Okay. So image width 128. If we go through everything, didn't complain, liked it. So what does our image look like now? And still this. Why? Doesn't make sense. All right, let's try it. Let's try to debug this. Let's see now. Number one, let me get rid of it to make sure that we are actually creating a new file to recycle bin. Okay, so now let's go ahead and let's. Are we still debugging? No. Okay. It stopped debugging. Okay, give it some time. All right, so let's do this. 43, 128, 128. This is 49152. Pad it. It should be 127. All right, yep. RGB is the bitmap. All right, for this piece, I want to kind of skip through it. Okay. And now, boom. Okay. It'll work. Oh, okay. That's odd. But okay. Yep, there it is. All right, so if we zoom in, there it is. Okay. I was expecting this to be at the top level, but that's all right. Okay. All right, so it works. What we did works. But now, what I want to do is I want to turn this into something that's able to do I wanted this to be able to do it iteratively. So what we need now is we need to get the files, and perform this operation for each of the files. So what we can do is let image get files equal to directory is equal to okay. And essentially what we want to do here is we want to get the directory of, we want to pass in a directory and we want to get all the files in that directory, but we only want to get those that contain, we only want to get those that are either PDFs or that are text files, right, in this case. So what we want to do here is we want to do file dot, no, directory dot get files, and then we want to get them from the directory, but then we want to filter. I was doing link syntax here. Okay, so we have an array. Now what we want to do is we want to array dot filter font x match x dot get where is the extension? Get name. Is it file info? No. Which one's the system IO to get the extension? Try to find this here. C# get extension. Oh, path.get extension. All right, so fun x okay, let extension if you go to path.get extension x or file path, okay, and then we want to tell it extension is equal to extension is equal to if extension is equal to .pdf or extension is equal to .txt, then file path. What the hell's going on here? I was expected to have type unit, but here it has type. Okay. What doesn't it like about this? If sharp operator or okay, symbols and operators. I thought this was the or, and I wanted to return if something is equal to, let's see, or. Okay, match expression. Okay, so this is for match expression. I want it to be for an or. Operators. Nullable. There we go. So this is and patterns for or. Is there no or? It's not right. Let's see. Boolean. There we go. Boolean or operation. So for us, it would be two things. For one, I want this. Okay. I screwed something up here. Right, so this is our Boolean operation, which is what we want to do. So it's two ands here. And for this one, it's if x equals to .txt or x equals to .pdf, then file path. Evaluate this side. This side. And then this. The expression was expected to have type unit, but here has type yeah, I mean, I can't do anything to it. So if it equals what? .txt and file path. Oh, I got it. Ah, it's so silly. Okay, so this is what it's expecting. Xt equals dot PDF, because I'm in a filter operation. Jeez. Or ext equals to PDF dot txt. There we go. Now it likes it. Oh man. I need to drink more coffee. Silly. Okay. So what was happening here was, so I was trying to basically do an if I was trying to do an if expression, but that's essentially what the filter is doing already, right? It expects a predicate, right? It expects a predicate with that's gonna evaluate a Boolean expression. And in this case, the Boolean expression was what we were trying to use for our if, right? We were trying to say if it's equal to PDF or if it's equal to .txt, take those, right? Give us the file path. Give us the file path. So, okay. So now this should work. And then what we can do now is we can tell it, hey, get files. Okay. So we can actually try it out. Let me go to Scratch. Let me go to my Scratch. FSX. Let's get rid of this for now. let's get rid of all this. Oh, um, file path. Yeah, we can get rid of this. Kind of comment this out, and we can then say, okay, get file bytes. Okay. All right, so files, get directory. So let's try this out. Wow, this thing is crawling. Okay. Oh, right. That's because I need this. Okay, now I have that. Okay, get files. And what I'm going to return is an array containing the files. So if I say, first of all, let me make sure that my source directory is right, right? And stream projects have an app. Okay, that makes sense. Now if I do, okay. Hey, Alex. How's it going? Thanks for joining. Let's see. So if we do main files equal to get files source directory, what we should, so what we're going to do now is we're going to essentially read the files. Let me sort of slim this down. And essentially what we want to do is we're going to want to check, we're going to want to read all the files in here. And the only ones that we're going to want to actually take out are, or to retrieve, are this PDF and a TXT file. Okay, so let's see, main files, and we can see here that that is the case. Let me just make sure. Main files, array.iter, fun, printfn, %s. Okay. There we go. Right. So we only got the TXT and the PDF. Awesome. All right. So now that we know that that works, just let me copy this to make sure that we got the right function. All right. We can add it to our application. All right. Get files. So then what we want to do now is we want to say get files equal to get files, and we want to do it for the current directory. Okay. We want to do it for the current directory. Then what we want to do is we want to go for each file, all right, basically do this. So are we going to do anything here? Files dot files, and it's going to be an array. So array.iter, right? And the reason why we're using iter is because, as opposed to a map where we want to return something, with iter we don't. We are essentially going to have a unit or a boolean, right? And what do we want to do with this is we want to do fun file path is equal to nope, fun file path. And then what we want to do is we want to stick this, pretty much all this logic in here, right? So I want to say get file bytes, file path. Okay. Now let's see, let file name is equal to path.get file name. Get file name without extension, right? So I want to get the path file name without extension. And the reason for that is we want to call this, we're going to want to call our image file the same as we're going to want to call our image file the same our as our file name. That way we can kind of identify it, except that it's going to be a JPEG as opposed to the original file name, right? So I want to do that. This kind of stays the same, right? Nothing changes here. Let iters, sure. So this is just setting the dimensions. This is setting the pixels. I mean, I actually am gonna move this all. Well, first let's make sure that this works, and then once I'm happy with it, then I'll sort of refactor this into its own functions, right? Okay. All right. Because actually, because what I could do is something like this: array.map, path dot. Well, I can't do that. Yeah, I can't do that. Yeah, that's fine. And then for this, what I want to do is let out file name is equal to file name as printf s.jpg, and then here what we want to call is just the file name, right? And then here what we want to replace this with is this out file name and file name path get file name without extension. Then we get the bytes. All right, I like this. I feel good about it. I'm just gonna debug this to make sure that I'm getting the right path before we do anything. So if we go here to the debugger, and then, there we go. Hopefully I did that in time. It's taking a bit of time. Let's see. All right. I'm gonna blame this on the fact that I'm streaming. All right, so files. If we step over. Cool. All right, I like this. Nice. This is exactly what I needed. Okay, perfect. So now that I have them, well, oof. I probably should have made sure that this was working. All right, no matter. Let's try it. Worst that can happen is it blows up. All right, so, all right, cd stamina, .NET build, and then we're gonna .NET run, and when it runs, I hope that it doesn't. Oh, .NET run. I should have added some sort of indicator that it had processed the image. And again, like in this case, is because there's only 2 images, that works. Okay, so it didn't complain. Now, if we go over to our files and we go to, okay, this is weird, but you know what? I'll take it. Fine. So here's our binary, right? And this one is my binary.txt, and it's this text representation, right? And then the stamina one is the white paper. And as we can see, though, it's small, right? It's small. And in the PDF version, right, is this. Stamina scalable white paper. There's that. Okay, awesome. This worked. Okay, so what we're doing now is, you know what? Let me check in those changes because I like it. Oh, no, 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 no. Get status. Get no. Yeah. Set head, and I want stamina app dot jpg. Status. Okay, yep, so. Oh, yep, I deleted that, and I removed these two, so now get status. And then the ones that are I am adding are these, okay. Get commit, updated, updated what? Updated, okay. Iteratively, okay, so can process multiple files. Okay. Get status. Get push origin master. All right. Commit directly to master. Okay. So I like this. All right. So now that we've got this, let me kind of talk a little bit about what I would want, what I'm envisioning this turning into. Okay, so now that we got this, what's going to be the next step? Or what are going to be the next steps? So the way that I see this happening is as follows. So we have Kaggle malware-analysis. Okay. So we have this data set here, the Kaggle malware classification. And what I want to do is, this is a pretty big file, or a pretty big data set. So where's the data? Okay. So the data set itself, it's 35 gigs zipped. Okay. So it's pretty big. I don't know what it's like without zipping or unzipped, uncompressed. So essentially what this has are 9 different classes of malware, right? And it contains the hexadecimal representation of the file's binary content. So again, in this case, it's going to be hexadecimal. For our purposes, we don't care what the contents of the file are. We just want to be able to get those into bytes and want to convert them into an image, right? And we've proven that we're able to do that, right? I want to try this out. Like once we download this data set, I want to try this out, and I want to be able to verify at least with 1 or 2 files, make sure that, hey, our this simple program that we just wrote, make sure that we're able to scale it, right? And we're able to do it across all of these files, right? With this multi-gigabyte data set, right? So we want to be able to do that. I'm not about to download all of these files onto my computer. I don't even know how much space I still have left. And even if I have this other external hard drive lying around, but even if I were to download it to the external hard drive, right, it may take some time, especially with streaming. As we can see, I'm having trouble just debugging my application. I can't even imagine what it would look like if we try to process all this data, right? Like I would basically have to leave my computer on all day, and yeah, it would just not be good. So what I'm thinking is I'm going to provision a VM, a pretty powerful VM on Azure. And then what we're going to do is we're going to run our script, get our application that we built to transform these files into images. And we're going to run it on this data set. And once we're able to do that and we've converted all of these files into an image, then what we're going to do is we're going to essentially then use ml.net and we're going to use its deep learning capabilities to build this malware analysis classifier, and we're going to see how it performs. So that's the plan. I think for today, this is a pretty good stopping point. Next Wednesday, what I'm going to do is we're going to go through the provisioning of that VM, and we're going to go through the downloading of this data. And in the meantime, while that's happening, we can fill it in basically with some of the content while that's happening in the background that we're downloading the data. We're going to fill in some of that time with essentially um, with you doing the workshops, which we didn't do this Monday again because I didn't stream on Monday. But we're gonna go ahead and do the workshops on Monday, the reactor workshops that are continuing to do data analytics and data science with F Sharp and .NET Interactive, and we're going to continue some of those on Wednesday as well while we're waiting for this data to download and sort of work. And then I have an additional idea of what we might want to do because just by looking at this, it seems like the training labels, right, or the classes that are associated with each of the files are separate from the training, the images themselves or the files themselves, right? So as a result, we're going to need to join this data, and we're going to need to perform some data transformations, among which is going to be creating these images, right? So yeah, so what I think is a good way to go about this may be using .NET for Apache Spark, and the reason for that is, at least with this text data, and the reason for that is Apache Spark shines in distributed scenarios, right? And we have big data, we need that compute, so we may just do this as a we're gonna try it out on a VM first, and then if that doesn't work, then we'll move on, and we're gonna try to do this in a .NET for Apache Spark cluster. But that's gonna happen on Wednesday, and yeah, I mean, I hope you guys learned a thing or two while we were trying to implement this, and I'm gonna be back on Wednesday. Sorry, on Monday of next week. But before that, again, please make sure to register for the virtual ML.NET conference. I'm sure you're going to learn quite a lot there. And yeah, see you next Monday. Bye.